Good titration. At neutralization. Good titrations. Neutralizations. Good titrations. Yes, we are talking about the great acid-base technique today of titrations. Titrations are a technique that is used to determine an unknown molarity of an acid or a base. A solution of known molarity is added drop by drop to another solution of unknown molarity by using a burette. Remember, that is the big long tube that is $80 that holds acids and bases. A neutralization reaction takes place. The solution is added until the equivalence point is reached. The equivalence point is when H plus equals OH minus. Okay? Do not get this confused with the endpoint of the titration. They are not exactly the same thing. This is when the color changes. It's actually over the equivalence point by a little bit. Okay? And we can see these color changes by using indicators. Indicators like phenolphthalein. Remember, phenolphthalein was colorless in acids and hot pink in bases. So when it's neutral, you see this very, very light pink color. Okay, let's go to the next page, because I'm thinking about good titrations, doing some acid-base neutralization. Good titrations. Okay, so here is what you use to do a titration here. This is the burette. Okay, this has the base in it. It has the known molarity. Down here is the acid. Okay, you get the volume of acid. You initially measure that. That should be our independent variable usually. Then you use your burette and you get a volume of the base. That is usually the dependent variable. Okay? And then you do everybody's favorite thing to do, stoichiometry, and you figure out the concentration. Okay? The equivalence point here is this point right here. This is where H plus equals OH minus. Below here, there is more H plus below. And above here, it's going to be more OH minus in your solution. And you're trying to reach the complete point of neutralization where H plus equals OH minus. Okay, so we are going to use stoichiometry to do this, just like our last unit here. Okay, so the first step here in stoichiometry here is we got to write down our reaction here. So 45.8.500 molar calcium hydroxide is required to titrate 25 milliliters of HCl. What is the molarity of HCl solution here? So we're going to write down a reaction here. So this is calcium hydroxide plus HCl. Ca goes with Cl. Ca is plus 2, Cl is minus 1, so it's CaCl2. And H goes with OH, making water. Okay, we have to balance the reaction here. We have two OHs, so we're going to put a 2 here. It gives us two H's, so we need to put a 2 here. Okay, so next thing I'm going to do is draw a map here. We are going to start here. Well, what are we trying to find? The molarity of the HCl solution. So I'm trying to find the molarity of HCl. Okay. So since this is a molarity problem here, this is where my double scribble technique works for this one. This is the one where I have a scribble on the top and the scribble on the bottom to solve. So since I'm looking for the HCl, I'm going to start off with the 45.8 milliliters of calcium hydroxide. You're going to go down to moles by using molarity. You're going to go over to moles of HCl by doing the wham 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 mole ratio. And then we're going to go up to molarity by using the volume. Okay. So this should be a 3-step problem here. Okay. So here we go. What are we going to start off with here? 45.8 milliliters. Okay. 45.8 milliliters. Calcium hydroxide. Okay. Remember, molarity, this is 0.500 moles of calcium hydroxide per 1 liter. Okay? So I have to first convert this over to liters before I use my molarity here. So we're going to put milliliters on the bottom, liters on the top. Okay? We know that there's 1 liter equals 1 times 10 to the third milliliter. Swish, swish. Now we're going to use our molarity here. This 0.500 moles of calcium hydroxide per 1 liter. Liters on the top, liters on the bottom. What am I going to convert to? 0.500 moles of calcium hydroxide per 1 liter. Swish, swish. Okay, the next step here is the infamous wham, 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 wham. Moles on the top, moles on the bottom. Calcium hydroxide goes on the bottom, and HCl goes on the top. Wham, 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 2. Wham, 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 1. Okay? And now we're going to do the double scribble thing here, because if we were to stop there, we'll be at moles. Now you can solve there and use your molarity formula, or you can put a scribble up here, and we know 25 milliliters is 0.025 liters. That's going to go down here. 0.025 liters. And then we will get an answer. And I don't have a calculator over here, of course. So I have to go get a calculator. Sadness. And we will get an answer. Three sig figs, 3 sig figs, 3 sig figs. So my answer is 1.83 molarity HCl. Easily done. Should we do another? We should. Of course we should. 50 milliliters of phosphoric acid. Oh, I need some right now. I could use some soda. It's titrated with 45 milliliters, 0.75 solution strontium hydroxide. What is the molarity acid here? So again, we got to write the reaction. H3PO4 plus SrOH2. H is going to go with OH to make HOH. Plus Sr and PO4. And remember, Sr is plus 2 and PO4 is minus 3. So this is 3 and 2. We have 3 strontiums here, so we're going to put a 3 in front of the strontium hydroxide. 3 times 2 is 6, so we're going to put a 6 in front of the water. 6 H's, 3 H's, so we're going to put a 2 in front of the phosphoric acid. Okay, again, this is the molarity of the acid here, so this is a double scribble problem. Double scribble. Just like double dribble back in the day, you know. This is double scribble. Oh, I should get the sound effects for that, you know. Get the old Nintendo game out there, you know. Okay, so here we are looking for the molarity of the acid here. So we are not going to start with the acid. We're going to start off with the strontium hydroxide here. So you're going to start off with the 45 milliliters of strontium hydroxide. You're going to use the molarity, convert it to moles, because when in doubt, go to moles. And then you're going to wham, 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 go over to moles of H3PO4, and then we're going to use the volume to go back to H3PO4. So here we are going to start off with the 45 milliliters. So hopefully you know that 45 milliliters is 0.045 liters of strontium hydroxide. Step 1 is to go to moles. Remember that this is 0.75 moles of strontium hydroxide per 1 liter. Yeah, it is. So, liters on the top, liters on the bottom. What are we trying to convert to? Moles. Swish, swish. 0.75 moles for 1 liter. That is what my molarity means. So we've done the first error. Now we got to do our wham, 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 whams to go across our bridge. Moles on the bottom, moles on the top. Let's see, moles of strontium hydroxide on the bottom. Moles of H3PO4 on the top. Swish, swish. Swish, swish. Wham, 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 wham. 3. Wham, 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 wham. 2. And then we're going to do to molarity here, so this is double scribble. Dun, 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 dun. Okay. And our last volume is 50 milliliters, so this is going to be 0.050 liters. And we're going to solve. I got 0.45 molal H3PO4. Technically, it would be 0.450 molal for sig figs. Okay, you guys are champions. The legend is out.